Hello everyone. Hope you guys can hear me. Just starting this great stream right here. So I'm going to come up with a system design for Instagram on the fly. I don't have not prepared for this. I'm just gonna wing it and see how far I can get, and hope you guys can get something out of it. And if you guys have any, by the end of it, I'm not sure if it's going to be a perfect system design for Instagram. This is my approach. It could be wrong. It can be definitely done in a better way. And if you guys have any suggestions, please leave a comment down below, and let's get started. So to begin with, I would say I think it will be best we scope out what we're going to design first, and then go from here. So my approach is going to be just um, ask questions and scope out what we're going to design, and obviously we don't have someone to ask questions, so I'm going to just scope out by myself, and then from there I'm going to um, sort of list out the the data that we need to pass around, like what data going to be we going to store, and how we going to send the data, and whom we going to send the data. So I'm going to scope those things out first, and then see how what is like come up with a capacitive planning of the load, and scope that as well, and then from there on I can go to a very high level design, and maybe dig a little deeper and make it a bit more detailed design. Okay, so let's get started. So the majority of the things that Instagram does, right, it lets you post and make a post, and have people like the post, and and users can view the timeline, right? Users can view their timeline based on their followers and the people they are following, right? Based on that, they can view the timeline, and also they can post and they can like. So let's keep it simple to those three uh, features. Let me note them down here. By the way, I'm using Lucid Charts here. It's a great app for diagramming. I use it all the time. Um, there's the tools like Miro and Raw.io. So I'm just gonna go with Lucid Charts, which is great for me. So what are things we need to know? So first, let's say create a post, and let's say just images for now. Let's not go into video. Um, we don't have to worry about encoding and transcoding videos for now. Maybe on another stream I'll show how that works. And what else? Like a post, and view timeline. So let's just keep it to that, and let's dig a bit deeper. So when it comes to creating a post, right? What are the data that we need to create a post? Let's sketch that out here. So we would need an ID for sure for that post ID, and let's call this post ID, right? And also we would need to know who created this post. So user ID, and also the important part of the actual post. Let's say the content. Um, it's best that we store this in a file storage, like an S3 bucket, uh, and have the link for that uh, file stored in the database. So let's say file path, okay, and what else? And the time that got created at, and what else? And the caption, right? Put caption here. Caption. So these are the data that we would need to identify a post, right? Who post ID, who created it, the file path, caption, and created that when it was created. And we can also store how many likes on the post, right? So say number of likes, right? We may need to change this, how we store number of likes, but for the time being, let's keep it here. So what else I can do? Can I make a box around this? Okay, never mind. Let's keep it as it is. So these are the for the to create post, right? Let's make it like this. Create a post. So like a post also have this information right here. Right. And timeline, right? So when we talk about timeline, we would want to view the post of users that a user is following, and by users that been followed by too, right? Right. So that way, we would want to know uh, per user. We want to know the followers count and the following count. So let's say user ID and followers. Followers IDs and following IDs, right? This could be a list of IDs and which will be pointing to another user table. And also we would want to know all the posts made by this user, right? We can have a list of post IDs too here. I'm thinking what's the best way to design this in terms of data. Um, just give me a second here, guys. Okay, sorry. Okay, I'm back. So, okay, we want to know, we want to do this in a better way instead of like having all the list of IDs here and list of followers ID and the following IDs. We could maybe create another schema called followers, just for the followers. So this schema would have a follower ID and the followed by ID. Okay, something like this. So this could basically point to the user, right? instead of having it here like this, instead of like storing a list of things like this, the user table, right? Let me name these tables so that will be much more easy to track. So we'll call this posts table. And let's call this users. And this let's call this followers. Right, and what else we can store here? We can store we can store like the name of the user, the and a URL to show the profile image, bio, right? Let's say a bio and a small bio and email, obviously, and these kind of things. And the user ID will be the primary key here, and post ID will be primary key here, and we'll have another list that combines follower ID and the followed by ID. So in terms of if we just map this out, so we'll have user, and we'll sort of have like a one-to-one mapping here. Let me line this up like this. So the user will have like many posts. So let's say, like, I'm trying to see if I can do that here. Yes, we do have this. So we'll have many users with many posts, and also at the same time user can follow many followers. Let's do it like this. Where is it? And at the same time user have multiple people following that user. Right. Let me organize this a bit more so it's easier. Right. Okay. So I think this will be a pretty simple set of data that we would need. So let's say if you wanna build like get the data we need for view the timeline, right? Basically, we for this particular user, right, we would want to get all their followers and using this table. And so basically, for example, this user ID will have an associated follower ID, and by that ID we can go and query all the posts for that particular IDs in that post table, right? And get all the posts and get the file path and build the timeline, right, as such. So this will be we can definitely have a better schema, but I think this is let's keep this simple. We can definitely have like a store more metadata for the post, but I think this is good enough for now. Right. And so yeah, so having this information, let's go ahead and create like a high level design for creating a post. So what do we need to create a post? So we'll have a client. Let me see if I can find a client here. Well, let's just use this client. It could be a mobile app or a web app that would need to make a request to post, right, to a backend server, or let's say an API gateway. Well, a large system like Instagram would have like multiple different services. So an API gateway would be where the request would come. So it will make a request over here, and this will route to a post service, right? That handles posting the image, right? And this will basically what would do is it'll create a it'll take the image or the content and put it in a file storage like an S3 bucket, and save the data into a database, right? Let's grab this one right here and save it in the database. So this is a very high level design, right? So if I walk through, if a person goes and posts an image, the request comes to the gateway, and gateway routes to the post service, and the post service stores the file in the file storage and create an entry in the database. Can be an atomic transaction. We can say basically if you create the file storage, create the file, save the file in the file storage, and create the database update before we send the update back to the client or the API gateway to forward the response back to the client, right? So that will be a simple design. So let's think about what are the places that this thing can go wrong. It can go wrong in like all these places, right? Client side, or in the API gateway side, or in the post service file storage side and database side. And I would say like file storages that we usually use like S3 bucket or any other, they are very resilient. They usually handle all kind of like failures on their side, so we don't have to much worry about that most of the time. But we definitely need to take care of this side. So let's start from the client side, right? So let's say, what are we gonna do? Like the client posts the request, and somehow the Wi-Fi got disconnected, right? What could we do? I think we could have a retry mechanism to keep on retrying to the API gateway, which will keep on failing. Or we can show a message to the user and saying that the posting the message failed, the user could retry. I think most app does that. I think that's more probably the better usage. Otherwise, it will be wasting resources on the client side to keep on retrying when there is no connection, right? We can show like a message on the UI, basically telling the user to try again when there's an internet connection, or try again in try posting it again in some time later, while storing the post in the client-side cache or client-side database like a SQLite, right? So that's one way to handle in the client side. And when you come back to here, so let's say we are good with the client side, and let's go to the API gateway. So let's say the request came all the way to the API gateway, but API gateway failed. And how would you handle that here? So that's where we do load balancing, um, those kind of things. Have multiple instances of the API gateway and have a load balancer in front of it in a round robin fashion, or like in a percentile basis based on the load. We send the request to one of the instances of the API gateway. That's a very established way to handle these kind of situations. So that's pretty straightforward. So if a request comes in, if a server is too busy, the load balancer can um, find a server that's less busy, and maybe idle, and pass the request down to that server. And that server, a gateway, will pass that request to the post service. And same as in the API gateway, post in the post service also we can have multiple different services, instances of the post service in front of a load balancer. Um, the the same way, have multiple different services in front of a load balancer, and the request comes in, and the load balancer routes the request to the more the low a cold service, or like a not heat or not a hot server, right? And that server basically does the does what it needs to be doing, save it in the store and update the database. Another way to do this is, let's say we have like all the services are busy, right? All the post services are busy, and how would that be handled? Let's say we have all the instances of the post services are busy. Um, Another way would be is to introduce a queue right here, not a hard disk, a queue, and have this server post the request over here. Obviously, this must be also this should be able to scale as well, similar to how these are scaled, right? And that way the queue won't get overloaded, right? So the request basically comes in, the API gateway posts that message to the queue, and have post service pull the messages and process it, right? And then what does it do in processing? It basically save the file in the file storage, and then update the database. This could be a Postgres database, and or any other, or even a MongoDB. But I think Postgres would be much better in this scenario, because we have a good relationship between the database. We need to the schema around the data. So I think it will be more easy to maintain, I would say. So this is, I think, an okay design to handle do these operations. So so that's how we would handle failures at each point. And the other most important part is the database. So what if the database gets high load, and post service, right? Update the database, and the database is really busy. So one way we could do is to have replicas of the database, and split up the read operations and the write operations separately. So we can have this database just handle the write queries, all the writes, and sync up with this other database that only used for reading. So the post service, so when someone updates it, it'll update this database, and it'll eventually sync up with the read database. So anyone wants to read this data would only need to go to this database, and anyone wants to write data only needs to go to this database. And this could be a cluster too. This can have its own write replicas, or like have something like what Cassandra does, has a consistent hashing, those kind of mechanisms, right? Um, so it will have multiple instances of that database, and have um, each request write to multiple databases. Or let's say we have multiple write databases here, say like as such, all write databases, and the post service or any kind of clients in front of the database can decide which database is less busy and route the request over to there. So let's say the request comes in, and let's say this database is less busy, the request will go here. And we can also have like a strong guarantee that, okay, we write to this database, and before we send the response back to the post service, we make sure the write gets synced up to this one, or and this one, and then we send the acknowledgement back. Or even we can just say, the as long as you write to these two databases, we send the acknowledgement. Or we just say, okay, you just wrote to one database, that's good enough, and for now, and you acknowledge, and it'll eventually sync up with the other write databases, and the other database, other post service also at the same time write to these databases. And so I mean, there are like you can ask questions, okay, what if it'll overwrite the same row, or like how it could sync up. There are mechanisms inside the database to lock the rows, and um, locking mechanisms with threading and everything. It's all handled with data inside the databases. So there are proven solutions to all those things, so we don't have to worry about it right now. And we'll have also a cluster of read databases too, that all eventually get synced up with the write databases, right? So we can have a system, resilient system like that, and that way we'll have a very good design for posting a post. So that's that. So let's say someone comes and likes a post, right? How would that work here? Again, let's say we'll have a like service, right? The API gateway would route the request to the like service. And also we can definitely have a queue here and make sure the like request doesn't get lost, right? So the request would come here, and it'll take here, and like service basically goes and writes to the database table, right? So these things, right, these kind of like eventually updating the read databases, when it comes to a system like Instagram, I think this is totally fine to do. No one's like gonna die, like knowing like immediate, like not knowing the immediate posts or immediate like updates around the world, right? I think this kind of design would be okay, unless if it's a bank, or unless some kind of an emergency system that needs to know things immediately, will have problems doing it this way. But this is fine, and this is easily the system can spread out around the globe for this. I mean, someone from United States does some updates to the database here, and someone from around the world in like India or Nepal can doesn't want to know doesn't I mean it's okay for them to know eventually the updates, right, as the database gets updated, right? And it's going to be really difficult, even if you think about the latency, right? Even they if we are going to connect, so let's say this database is in US East Coast, and someone from the uh, other side of the earth trying to connect to this database, the latency is going to be huge, right? So a better design would be it'll their databases stay in their region, and it eventually syncs up with the database on the US region. I think that kind of design is a lot better. So that's that, and so liking a post is that, and now comes to let's go into dive into the view timeline design, how we're going to design. So again, a user comes in and they want to view the timeline. How are we going to generate that? So we can obviously set up queues to get requests and all those things, but that's not going to be great, right? When someone opens the Instagram app, they want to see the timeline immediately. They don't want to wait until the request goes here and read the database and aggregate them and comes back, right? So if you see here, it needs a lot of aggregation based on the schema, right? Um, I mean, we definitely. I mean, you can say we can have all the posts saved in the same schema, but that's going to be ugly, even with no SQL, right? So a better design would be uh, we'll have a different database that pre-generates this data, right? Kind of periodically. Um, it's gonna go and query this database, and for each user, right? It'll go there periodically, go and find their followers and their post, and aggregate all those information, store it uh, in a different database uh, prominently. So whenever the user comes, they just go straight away and take that database and return that data back. And we can also set up a cache in front of that service, and so that way it'll be much faster. So how would that be? So let's call this timeline service. And we can also have this service multiple instances of the services that can horizontally scale, and the request comes in to this service, and what this service does, it's gonna just pull the data from not this database, it's going to be a different database. Okay. Before I go into this sort of the client side thing, let's just first figure out the back end, how it's going to be, how it's going to aggregate the data. So let's call this the aggregation timeline service. Timeline aggregation service, right? Just call it that. I mean, we can have like multiple threads, multiple workers that goes on and pull stuff from this database, aggregate it, and store it in this database. Okay. Likewise, we can definitely have multiple instances of this database too, for scalability reasons. And I'm just gonna do this here. And the timeline service is simply going to pull stuff off of it. And uh, definitely this can it can definitely cache some of the posts that been most frequently viewed. um, so we can set up a cache in front of this. Use this for cache. Like Redis or Memcache would be a perfect fit for this. And yeah, so this aggregator will go and pull stuff off of this database, build it, and store it in this database. And this service will go and pull, and you can simply display that to the client. So I think this is a good enough design for this set of uh, requirements. So and this can easily scale well too, as users increase. And yeah, and I don't see any single point of failures anywhere. And even this could be a cache cluster instead of just one cache. Yeah, and these queues could be Kafka too. You mean Kafka can instead of this queue can be replaced with Kafka. It's very scalable, and we have one Kafka cluster for separate topics for post for the post service, and separate topics for like service. And um, these could be in the consumer group that pulls topics from this Kafka, and this should be another consumer set of group that pulls stuff from this Kafka service. And Kafka cluster. And yeah, and this could be in Kafka too, uh, but for why? That's a good question. Um, Maybe you could connect this to, I mean, definitely we could connect this to a Kafka cluster. Whenever it creates a post, it update the cluster. It could send a message to the Kafka cluster, which get picked by another analytics service that tracks analytics, right? So yeah, I think this should be a good enough design. Yeah, and um, leave a comment down below what you guys think about this design and any improvements that I could make. I didn't go into the capacity planning in this video, in terms of like storage capacity, those kind of things. Probably look into those things in another video. Maybe another improved design for this architecture. Yeah. So anyway, thanks for watching, and like and subscribe to my channel. Bye.